I have a bone to pick with gears in video games. Some games use it for non-gameplay decorations to emphasize a mechanical or steampunk environment. Some use mechanisms as part of their gameplay, but use animated gears as simple keys. Some aren't even trying. Anyway, I've yet to find a game that makes use of gears as puzzle elements. I think picking what gear to put where inside a mechanism could be very fun. If you know of any game like this, please let me know in the comments. Today we'll see if we can make a small puzzle game about gears and if it's any fun to play. Hi, I'm Leonard, and welcome to Useless Game Dev. What's so interesting about gears is that the number of cogs or teeth on a pair of wheels will have an impact on speed. If you have a gear that spins really fast and you add a second gear with twice the number of teeth, the speed will be divided by 2 and incidentally the torque will be doubled. I don't think Unity's physics engine is going to be able to support a complex mechanism, let alone using an actual gear shape. But still, let's try it for fun, and also because if it does end up working, it's going to be a very short video. So far, so good. Surprisingly okay, although quite tedious. And it's broken. The first thing we need to do is to generate gears based on the number of teeth. That's simple enough. So let's say we have multiple gears. Each gear has a list of the neighboring gears it's connected to. And one or more of those gears is a driving gear, which means it has a manually set speed and is not driven by its neighbors. We'll then start from the driving gear and recursively propagate the movement for every gear in the chain. Unless it's a driving gear, the speed of the gear is equal to the speed of the parent multiplied by the ratio of teeth in both gears. Oh, and obviously the direction should be inverted. Sometimes, despite your best efforts, some mechanisms are just not going to work. Because speeds or directions won't match, we need to detect when a chain of gears is blocked. To do this, before setting the speed of a gear down the chain, we'll check whether its speed is already set. If it's set to a value that is significantly different than what we're expecting it to be, this means we're in a bad chain, and we need to recursively propagate the news that these cogs won't turn. There's a second way speed can be transmitted, and that's through joints. When elements are joined together, they have the same speed and the same direction, so our recursive function should reflect this also. After a little bit of refactoring, I now have a gear and shaft class, which, after the surprisingly painful development of a joint system, can now dock together, and that's cool because we're now able to make multi-stage mechanism. That's where the real fun begins really, because we can take a super fast wheel and add a ton of reduction to the speed. If you want to see what that looks like in real life, I suggest heading over to the Brick Experiment channel and watch them create a Google to 1 reduction ratio with Lego gears. Anyway, I made a few puzzles where you need to pick the right gears to transmit movement to another gear and open a door. Then I moved on to more complex puzzles where doors have a minimum torque requirement to force the player to think about what gears to use. And since it worked okay enough, I decided to actually build this into a working game. It's called Clockwise Temple and it's available in the browser on itch.io. You can play it right now if you want. It's not a ton of fun because it gets repetitive very fast and placing gears can get finicky, but the last levels with multi-stage puzzles are somewhat cool. Go ahead, play it, this video is over anyway. Thank you for watching and have a good one.